In this question, we're asked to find the vertical asymptotes of the graph of a function. Let's do number 19. So I have x cubed over 2x cubed minus x squared minus 3x. To find vertical asymptotes, I'm looking for values of x down here that are not part of the domain because it's at that point where there's an asymptote. So the top number doesn't really matter unless you can cancel something out. And I think in this case you can. So I've got x cubed over, let's factor the bottom. I can take a common x out, so it's 2x squared minus x minus 3. And then, I can cancel out this x with one of those x's there. So what I'll have is x squared over 2x squared minus x minus 3. Now let's factor the bottom. So I think I can go 2x and an x, probably a 1 and a 3. This one's probably negative and this one's positive. Let's just check that. 2x squared plus 2x minus 3x is a minus x minus 3. Yeah, that's right. Okay, so now that it's factored, they don't ask me, but I could say in the domain, then, either 2x minus 3 can't be 0, or x plus 1 can't be 0. So I'd move the 3 over and divide by 2. So on this one I get x is equal to, or x for the domain, I'd say x is not equal to 3 halves. And this one I'd say x is not equal to negative 1. So that would be the domain, or all of the allowed x's. If I want to specify what are the vertical asymptotes, they are the same thing except equal to. So the vertical asymptotes then are x is equal to 3 over 2 and x is equal to negative 1. In other words, on the graph at negative 1, that point right there, and positive 3 halves, right about there, there will be vertical lines that the graph cannot pass through. So the graph might come close to that line, but it can't touch it. And I'm not sure how this graph looks, but it could look something like that, where the graph gets close to this vertical line, but doesn't touch. So the equation of the vertical asymptote is x equals this, x equals that. The domain are all the x's that work on this graph, except for those numbers, because it can't cross there. Hopefully that helps.